Hello children, in the previous lecture I discussed about Wheatstone's bridge, and in today's lecture I am going to discuss about Metre Bridge. Okay, Metre Bridge. Metre Bridge is an arrangement which works on the principle of balanced Wheatstone's bridge. It is used to find the unknown resistance. So let us draw the diagram of Metre Bridge first. These three are copper strips. These are L-shaped copper strip and this is an I-shaped copper strip. These three copper strips are fixed on a wooden plank. Okay, wooden plank. You will also see it whenever we will start practical classes. This is a wire whose length is 1 meter. Here is a meter scale just under the wire, and the length of this wire is 1 meter. This is the meter scale under the wire. This is 0 and this is 100. Means in centimeter calibration is made. Here are some connecting points. We connect an unknown resistance whose resistance is to be measured either between these two or between these two. You see, I am connecting it here. This is X. You have to find the value of X. Here is a resistance box. Value of resistance box are written on different keys, and whatever key you will take out, bring out. Okay, the resistance offered by the box will be that. So this R is a known resistance and this X is an unknown resistance. You have to find the value of this X. You can mark these two as points A and B. You mark this C, D, E, F and H. We have not written G because G will be used for galvanometer. You connect a galvanometer here and have a jockey in the galvanometer. Got it? After then, you should connect a source of EMF here. This is the key. Whenever you will switch on the key, the current will pass through this wire and through the strip. passing through this unknown resistance X and R. You just slide the jockey over the wire. This wire is made of constantan or magnene. Constantan and magnene are alloys, and we use these alloys in place of a conductor because the resistivity of these alloys is very high and the temperature coefficient of resistivity is low. Means even if a temperature will increase slightly, there will be almost no change in the resistance. This is the reason that we take constantan or magnene as the wire. Got it? So you can be asked in examination that what is the reason that we use constantan or magnene as the wire. Okay. Now what we do, whenever we switch on the circuit and current is passing through the arrangement, we just slide this jockey J over this wire, constantan or magnene wire. This is the reason that this arrangement is also called slide wire bridge. Slide wire bridge. Slide wire bridge. And the length of the wire is 1 meter. So it is called meter bridge. Got it? Now, whenever you will start moving, sliding the jockey along the wire AB, there will be one and only one point on the wire at which, if jockey will be placed, galvanometer will show no deflection. That is, there will be no current through the galvanometer. Suppose this is that point J, and this point is called balance point. What does it call? It is called balance point. Got it? So J is here a balance point. Now just draw an equivalent circuit which is like a Wheatstone bridge on the basis of this meter bridge. You see A and C are connected by copper strip, and you can observe that copper strip is thick. Thick copper strips are used so that they do not offer resistance. Okay, means these strips do not offer any resistance. It means there is no potential difference between point A and C. There is no potential difference between point D, E and F. There is no potential difference between H and B. Okay, you can also say that C and A are at the same potential, D, E and F are at the same potential, H and B are at the same potential. So if A and C are at the same potential, we can represent a point A and C. Means both A and C are at the same point. Got it? D, E and F. Suppose this is the point at same potential D, E and F. This B and H. Suppose this is B and H. Same point. And jockey J, it represents another point. You see there is a resistance X between C and D. So you connect a resistance X between C and D. There is a resistance R between F and H. So between F and H, you can connect a resistance R. And there is a wire CJ from A to J, AJ or CJ, whatever we can call it, it will be correct. BJ is constantan wire. And you know the resistivity of constantan is high. So this small part of wire will offer a resistance. Means it will be treated as a resistance coil. Suppose the resistance of this wire and this wire are some finite value. if small r be the resistance per unit length of this wire and L be the length of this portion AJ, then what will be the length of this portion? 100 minus L centimeter. This is L centimeter. Okay, and small r is the resistance per centimeter of the bridge wire. This is also called bridge wire, made of constant or magnesium. Then what will be its resistance? R is resistance per centimeter and L is the length. So its resistance will be R into L. And its resistance will be R into 100 minus L. Got it? You see there is a galvanometer between E and J. So there is a galvanometer between E and J. And this galvanometer shows no current. That is no deflection. So can you think that this circuit is just like a meter bridge? You see one resistance, other resistance, third resistance, fourth resistance. No. So if you will apply balanced bridge condition, then by Wheatstone bridge principle, Wheatstone's bridge principle, what will you get? You will get X by RL is equal to R by R into 100 minus L. You see these two R will be cancelled out and ultimately you will get X is equal to L by 100 minus L into R. So you already have capital R and you can find the value of X. Got it? Now suppose you have taken this as R and this as X, then what will be the expression? Expression will be X is equal to 100 minus L. It will become 100 minus L by L into R. Okay, so whatever you take, it totally depends upon whether you are taking it as X or you are taking it as X. Okay, formula will come accordingly. So please never be confused by taking any of the two, this and this, as X means a known resistance and other as the known resistance. You will also perform the experiment related to this concept in your lab. Whenever the school will reopen, we will have the experiment related to this. Okay, thank you.